If you've ever kicked off a major project, you know the scenario. You start with this big detailed plan, but as soon as the real work begins, requirements mutate, or maybe a massive technical risk, something nobody saw coming, pops up,
Oh, yeah.
and it threatens to derail the whole endeavor. When complexity and uncertainty are highest, those purely linear, sort of rigid development models, they often just crumble.
It's the ultimate project management paradox, isn't it? The more unknown the territory, the higher the risk. Yet, well, traditional systems kind of force you to commit to a fixed destination before you've even properly started.
Exactly.
Yeah.
So today we are deep diving into the model designed specifically to solve that problem, the spiral model. It's the framework preferred for high-stakes, mission-critical systems.
Right.
Our mission here is understand how this model manages to merge the necessary discipline of structured methods with, the essential flexibility of iteration, all while making risk analysis its primary job.
And the core idea is simple, yet honestly brilliant. The spiral model combines the systematic, step-by-step control of the waterfall model.
That controlled flow.
Precisely. With the continuous refinement of iterative development, but, and this is key, it places a very high emphasis on risk analysis. It is explicitly designed to handle those unknown risks that might pop up after development has already begun,
Okay.
allowing the product to mature and release incrementally.
Okay, let's unpack this hybrid nature then.
Hmm.
Starting with the origins. Who actually conceived of this Frankenstein's monster of project management?
Well, the model was first proposed by Barry Boehm back in 1986. And what makes it so powerful is that it wasn't starting completely from scratch. It's really a synthesis, pulling the best proven ideas from three predecessors.
It sounds like it's standing on the shoulders of giants while maybe looking in four directions at once.
That's a powerful distinction, actually. From Waterfall, it definitely takes this systematic sequential structure. You have to
Yeah.
complete one phase before moving to the next, at least within a single loop.
Got it.
From the iterative approach, it incorporates continuous customer feedback. Very important. And critically, from the prototyping model, it mandates developing these, well, sometimes throwaway solutions, prototypes, to solve problems before you commit the full resources to the actual development.
So it's not just one recipe for success. It's more like the entire cookbook for project management in certain situations.
That's the core idea, yeah. It's often known as a meta model because it acts as this sort of overarching operating system. It defines the framework that dictates when and why you might deploy a simpler model.
Oh, okay.
So using a linear waterfall approach for maybe a low-risk, well-understood part of the system, or perhaps a pure iterative model for just the user interface design, all within the larger spiral structure.
That gives great context.
Okay.
Now let's get into the visual structure because the name spiral itself, it's a visual metaphor for cost and progress. So for you, the listener, imagine a continuous loop starting small in the center and just expanding outward.
Mm-hmm.
A software project repeatedly passes through four main phases in these cycles, which, well, we call spirals.
And this diagram, it's really more than just a picture. It's like a living strategic insight tool.
And here's where it gets truly transparent, I think. Unlike a static timeline, the actual physical shape of the spiral communicates critical project metrics. The radius of the spiral, how far you are from the center, that represents the total expenses or cost accumulated so far.
Right. Exactly. And the angular dimension, so how far you've moved along the current loop, that represents the progress made in the current phase.
Okay.
So every time you complete a loop and that radius gets wider, you are visually and transparently acknowledging that the project's cost base has increased. It forces visibility on spending.
That's a brilliant way to quantify transparency. So every time that radius expands, the budget holder knows exactly what they're paying for, in theory. Let's detail those four crucial phases, the quadrants you cycle through in every single iteration.
Okay, so the first quadrant is identification, objectives defined, and planning. Now, in the baseline, the very first spiral, this involves the initial requirements gathering, lots of communication with the customer.
Kickoff stuff.
Exactly. In the subsequent spirals, you refine this, identifying specific system, subsystem, unit requirements, defining the estimated costs, schedule, resources needed for the next loop.
Okay, so if the first phase is setting the course, the second phase sounds like where the spiral model earns its entire salary. Tell us about risk analysis.
That is the risk analysis and resolving phase. And yeah, it's the centerpiece. This is where you proactively identify, estimate, and monitor technical feasibility risks, but also management risks, things like schedule slippage or cost overrun.
The scary stuff.
The stuff that keeps managers up at night, yes. The main output here is finding solutions and planning a formalized risk mitigation strategy. And this is often where prototyping comes in, specifically building a small prototype to test the highest risk elements before actual construction begins.
So you actively try to fail, but cheaply, on a model so the expensive full system doesn't fall over later.
That's precisely the idea, a necessary trade-off. Once those risks are mitigated or at least understood, and the plan is stable for this loop, you move to the third quadrant. Construct or build or engineering.
Right.
This is the actual production of the product for that cycle. Early on, it might just be a small proof of concept, POC, mainly for initial user testing or feedback.
Okay.
In later spirals, you produce actual working models called builds, often with version numbers involving design, coding, testing, and these are then passed to the customer.
Which leads naturally to the customer checkpoint, I guess.
Exactly. The fourth quadrant is evaluation and plan for the next phase. Here, the customer evaluates the current software build, gives their feedback. The team then assesses any new or remaining risks based on that delivery, and the planning for the next iteration begins, incorporating that customer feedback directly back into the loop.
And the crucial takeaway here is that the process just continues. You keep cycling through these 4 quadrants until the requirements are clearly met, the customer is genuinely satisfied, and the product matures with each expansion of the spiral.
It's synchronized with the natural process of any complex endeavor, really. You're learning with maturity. This makes it an excellent choice, generally, for minimizing risk for both the customer and the development firm.
It definitely sounds like overkill for, say, a simple mobile app or maybe a low-stakes internal tool. So when does the spiral model truly shine? Where is it indispensable?
Oh, absolutely. It's overkill for simple tasks. It's inherently complex and, frankly, expensive. It shines in environments that are really high risk or mission critical. Think large-scale aerospace projects, maybe at organizations like NASA or ISRO, where failure is just not an option.
Right.
It's also ideal when requirements are inherently unclear, complex, or continuously changing.
That makes perfect sense. If you have changing requirements, you absolutely need a flexible framework. But doesn't constant customer involvement, combined with stopping every loop for intensive risk analysis, doesn't that just make the entire project balloon out of control? Like, when does the real construction actually start if we're always stopping to check the map?
Well, that is the fundamental tension you have to manage with the spiral model. The construction is the iteration, in a way. That risk analysis in quadrant 2, it's what prevents you from building the wrong thing, or maybe building the right thing, but on a faulty foundation. It's really an investment in stability down the line.
Okay, fair enough. Give us a tangible example then. How would a project manager use these spirals to develop something familiar, like a new e-commerce website?
Okay, yeah, let's trace the strategic progression. In the first spiral, the team defines the basic scope, product listings, maybe a basic cart, payment ideas, and they'd quickly identify the massive initial risks. Scalability and security are usually huge for e-commerce.
Sure.
They might use the engineering quadrant then to produce just a simple homepage proof of concept, mainly to test user interaction assumptions and maybe initial infrastructure stability. Nothing too complex yet.
So the goal of Spiral 1 wasn't a working website at all, but really validating the riskiest assumptions first.
Correct. Then, in the second spiral, based on that initial feedback, they'd address the highest priority risks identified. This could mean heavily testing payment gateway security, maybe running traffic simulations to address scalability concerns. They then integrate basic cart functions and perhaps user registration systems, sending those functional but still limited builds back for customer review.
Okay, moving into deeper feature implementation now.
Exactly. The third spiral would then focus on a more detailed implementation of major features, things like order tracking, customer reviews perhaps. They'd definitely revisit scalability risks, maybe performing heavy load testing, specifically simulating busy shopping seasons to ensure the architecture holds up.
Right.
The customer feedback here really helps prioritize which features add the most value and helps adjust the plan for the final version.
And then the final phase before launch, presumably.
Yes, the final spiral wraps up all the agreed requirements. The entire system is thoroughly tested, security might be audited one last time, and then the site launches. But even then, the evaluation phase kind of continues by monitoring live traffic and user feedback to capture and address any remaining risks, which effectively becomes the maintenance phase, still potentially following spiral principles for major updates.
That systematic, structured mitigation of risk is clearly the #1 advantage.
Mm.
What else stands out on the upside for someone using this framework?
Well, beyond the excellent risk handling, you gain tremendous flexibility. Because you plan for change, incorporating new or modified requirements accurately, even quite late in the game, is built right into the process.
That's huge.
It is. Also, customer involvement is high and continuous. Users see working system elements early, they provide feedback, and crucially, they tend to develop a sense of ownership over the system, which can minimize the shock of the final launch. They're used to it already.
But every project manager knows that if something sounds perfect, it's usually expensive or complicated or both. What are the substantial trade-offs for all this structure and flexibility?
Oh, they are substantial. First, it is exponentially more complex and costly than simpler models like Waterfall. It's just entirely unsuitable for small or genuinely low-risk projects.
Okay.
Second, and this I think is the biggest vulnerability, its success is highly, highly dependent on highly specific expertise for that risk analysis phase. You absolutely need experienced professionals who can spot technical and managerial risks that haven't even fully manifested yet.
Wow. So if you don't have the right people, the wizards, to spot the dangers ahead, the whole safety structure you build just kind of collapses. That's a huge dependency.
Absolutely. It also requires incredibly strict management discipline. If you remember that evaluation phase in Quadrant 4, the decision to proceed to the next iteration, or maybe even to terminate the project if risks are too high, that decision must be rigorous.
Because if you don't impose that discipline, you risk the dreaded infinite loop, right? It's like the business equivalent of continuously remodeling your kitchen just because you saw a new tile color on Instagram this week. How do you actually put a governor on that freedom to change?
That is the project manager's nightmare indeed. The constant potential for continuously changing requirements means the end of the project is often not known early on, leading to real difficulty in time and budget estimation.
Right.
That management discipline is the mechanism for saying, yes, we could add feature X, but the risk analysis shows its impact on the schedule or budget is too high for this current spiral.
Yeah.
You have to be willing to terminate unnecessary loops.
Is there a final disadvantage we should cover?
Well, just the sheer volume of work in those intermediate stages, all the planning, risk mitigation reports, potentially multiple prototypes, it requires excessive documentation. It's definitely heavy on resources and maintaining that paper trail.
Okay, so to summarize our deep dive then, the spiral model seems like the strategic choice for projects really defined by high risk, high cost, and often uncertain or evolving requirements. It acts as a disciplined, risk-mitigating framework for what could otherwise be chaotic development, provided you have the resources and, critically, the expertise to handle that constant reevaluation.
It absolutely allows you to develop high-quality, adaptable software by embracing iteration and continuous client feedback, ensuring the product stays relevant to changing needs over its lifespan.
But let's leave you, our listener, with this provocative thought to mull over. The spiral model demands strict management to successfully complete a project. Yet its fundamental strength relies on the freedom it gives developers and customers to allow changes and iterate, potentially indefinitely. So how do you, perhaps as a project leader, decide when the risk of that infinite loop outweighs the benefit of one more cycle of refinement? What concrete management mechanism do you actually put in place to declare the project successfully finished when the entire framework is built to suggest you could always go for just one more loop? Think about that hard boundary as you plan your next major undertaking.